Hello there, this is an Algebra 2 video. It is Chapter 8, Section 6, and today we will be discussing how to solve a rational equation. And so we have an example here. And to solve a rational equation, it's going to be easy to solve these if you try to find the least common denominator first. Instead of trying to combine them into one fraction, what we want to try to do is get rid of the fractions altogether. And we can do that if we can get rid of, if we can find the least common denominator. So, for example, I know that we have a 6 here, which is 2 times 3, and 18 here. So the least common denominator is going to be 18 and x plus 3. So what you want to do is multiply each individual fraction by, well, let's not to be lazy, and I'll write it all out for you. So what I want to do is I'm going to take the 18 and the x plus 3 and multiply it by the 4 over x plus 3. I'm also going to take the 18 and the x plus 3 and multiply it by the 5 over 6. And I'm also going to take and multiply the 18 and the x plus 3 times the 23 over 18. So basically what I've done is I've taken each fraction in the original equation and I'm multiplying it by the least common denominator, which is 18 times x plus 3. What that's going to do for us, it's going to allow certain things to cancel. So for example, in the first fraction over here, the x plus 3 is going to cancel. And you're going to have 18 times 4. And I'll get my trusty little calculator here. And it turns out that 18 times 4 is 72. So that'll leave us with a 72. And then over here, the 6 is going to cancel with the 6 from the 18, but that's going to leave us with a 3 because 6 times 3 is 18. And the x plus 3 is still going to be there, so I'm going to get 3 times 5, which is 15, and the x plus 3 will remain. And then on the very end over here, the 18s are going to cancel, and you're going to get 23 times x plus 3. And now what we've done is we've eliminated the equation from any of the fractions that were there originally, and now we can solve it like we normally would. So we're going to distribute the 15 here, 15x plus 45. Distribute that guy, and over here we're going to get 23x plus 69. 23 times 3 is 69. So then we're going to combine our x's and our constants. So you want to bring this 23x to this side with these 15x's. And then we also want to take the 72 and the 45, and we want to subtract 72 and subtract 45. So at the end of the day, we're going to get 15 minus 23, which is negative 8x on the left. And on the right, we're going to get 69 minus 72 minus 45, which is negative 48. And then we divide by negative 8. And we end up with a positive 6. Alrighty, so now the last thing we want to do is actually check our solution, because sometimes when you have a rational equation, you can end up with an answer that is not part of the domain of the original function. In this case, we would have issues with domain if x was negative 3, but since x is not negative 3, x is actually 6, then we know that this will actually work. So our solution for example 1 is that x equals 6. And then we want to let you try this, do it yourself. This is part A. And here we have part B. And then we're going to go to our next example and just kind of take it up a notch. So the difference with this one compared to our example 1 is that you are going to require some factoring before you can figure out what the least common denominator is. So what we're going to do is we're going to take this fraction here and we're going to try to factor it. So we're going to have, I'm going to rewrite the 2x over x plus 5. I'm also going to leave some space for myself so I can come in later and multiply it by the least common denominator here. But on top, we're going to get, I'm going to use my little factoring method. I'm going to have x and x to get x squared. And then we're going to try maybe 5 times 2. That will give us 10. But we want a negative x there. So, let me see here. I don't think we can factor the top actually, because there's no two numbers that are going to multiply to get 10 and also add to get negative 1. So the top will not factor, and that's okay. We're just going to go ahead and write the x squared minus x minus 10 again. But on the bottom, we are going to factor that part, and that one I know will factor. So we have x and x, and then to get 15, you're going to want to do 5 times 3, and if you add 5x and 3x, you get 8x, which is what you have on the bottom. So in this case, the bottom will become x plus 5 and x plus 3. And we'll go ahead and get rid of this factoring guy over here. We don't need him anymore now that we've factored. So, and then I'm going to leave some space again, and then we're going to have 3 over x plus 3. So here is my factored equation. And now when I look at the factored form, it's clear to see that the least common denominator is going to be, every factor has to be represented. So I see x plus 5, so definitely need an x plus 5, and you also have x plus 3 as part of the denominator. So my least common denominator is going to be the combination of x plus 5 and x plus 3. So now what I do is I take each fraction and multiply it by the least common denominator, which is x plus 5 and x plus 3. Multiply the second fraction by x plus 5, x plus 3. And also the last one by x plus 5, x plus 3. So now you can probably see why I was wanting to leave some space there so that I could go back in later and plug in the least common denominator. So now the x plus 5 will cancel here, and you will get 2x times x plus 3. Here, both x plus 5 and x plus 3 will cancel. Now you do have this negative that needs to get distributed to all of this, so this is actually minus x squared minus x minus 10, and then equals, and over here we're going to have the x plus 3's cancel, and you're going to get 3 times x plus 5. So now we can actually distribute, so 2x times x is going to give you 2x squared plus 6x minus x squared plus x plus 10 equals 3x plus 15. Then we're going to try to combine everything together. We want to bring the 3x's to this side, and we want to bring the 15 as well, and maybe have it equal to 0, and we'll have a nice little quadratic. So we have 2x squared here. 2x squared minus 1x squared is going to give you just x squared. Then we have 6x minus 3x, which is 3x, and then 3x plus this x is going to be 4x. And then we have 10 minus 15 is going to give us a negative 5 equal to 0. And at this point, we can try to factor our quadratic. And if it doesn't factor, you can always use the quadratic formula to solve. But I do believe that this will factor. So we have x and x. And to get 5, you have 5 times 1. But you want a positive 4. So if we take positive 5 and subtract 1, if my pen will work with me here. There we go. Then if we go 5x minus 1x, we will in fact get 4x. And so that's our factorization. So we're going to go with x plus 5 and x minus 1 as our factorization. And that means that x equals negative 5. So if you take each of these individually and make them equal 0, then x will equal negative 5 and x will equal positive 1. Those are our two possible solutions. But when we check those solutions, like I said before, we know that we can't have negative 5, because if you have negative 5, then you would have division by 0 in this scenario. So that's what we call an extraneous solution. So we don't want to include a negative 5. So our actual answer is only going to be the x equals 1, because that one won't cause division by 0. So there we go. Now we're going to let you try 4 on your own. This is part A, B, C, and yes, D. All right, and then we're going to go to some application problems. And so here we're going to start with a mixture problem. It says Mia adds a 70% acid solution to 12 milliliters of a solution that is 15% acid. How much of the 70% acid solution should be added to create a solution that is 60% acid? So basically what's happening here is you have different strengths of acid. I know it sounds kind of wordy, but basically you have 12 milliliters to start with of a 70% solution, which is kind of strong. So what you're trying to do is dilute it, because at the end of the day you want a 60% solution, which is obviously not as strong as a 70% solution. So you're going to add this 70% solution. Oh, I'm sorry. We actually want to make it stronger. I totally read that wrong. Basically, you have 12 milliliters of a 15% solution. All right, so you have a weak solution, and you want to add to it the stronger 70% solution, so that at the end of the day you only have a 60% solution. You don't want it to be as weak as 15, and you don't want it to be as strong as 70, but you want it to be 60% acid solution. So we can create a little scenario here. So what we know about percentages is that you have the percent. Well, let's abbreviate that word. We don't need to write out the whole percent here, but basically the formula goes something like this. Percent over 100 equals the part over the whole. That's kind of, in a nutshell, how you get percentages. Okay? So what we need to figure out is, we know the percent that we want. The percent that we want is 60%. So we can already write out 60 over 100 in this part of our equation. We already know that it's going to be a 60% solution. But we want to know right now is the amount of acid, because that's the part is the acid, the amount of acid that we have compared to the entire amount of solution that we have. Okay? So to do that, it's not that complicated. We know that the amount of acid that we have is 70% and 15%. So first, we know that we have 15% acid in this 12 milliliter solution. So basically, we're going to take 0.15, which is 15%, and times it by 12. And that'll tell us how much acid we currently have in this mixture. And then we're going to add a 70%, which is 0.7, of an unknown amount. Okay, so that's how it works. Okay, we have 15% times 12 milliliters, and then we have 70% times we don't know how many milliliters. That's the question we're trying to answer. All right, so we have that for the acid. And then as far as the total amount, we know that we have a total of 12 milliliters, and we're going to add to that X milliliters. Okay, so that's how we're going to set up our problem. So basically the acid is on top, so we're going to take 0.15 times 12. So that calculator is on a battery. So we'll take this one. 0.15 times 12 is going to give us 1.8. So right now we have 1.8 milliliters of 15% solution, or I'm sorry, we have 1.8 milliliters of acid, because we have 15% of 12 comes out to 1.8 acid. What we don't know is the X, so we're just going to write 0.7X like that. And then how much solution total do we have? Well, we already have 12 milliliters, and to that we're going to add an X amount. So basically that's your equation right there. So that's going to be the hardest part of the problem, is actually setting it up. So now to solve it, we want to, again, multiply by the least common denominator. So in this case, you could actually do it two ways. You could go ahead and multiply both sides by 100 and 12 plus X, because that's the least common denominator. Or you can actually, in this case, use cross products to multiply it. But I'm going to go ahead and be consistent and do what we've been doing, which is to multiply by 100 times 12 plus x on this side and multiply by 100 times 12 plus x on the right hand side. So over here the 100s are going to cancel and you're going to get 60 times 12 plus x on the left. On the right, the 12 plus x will cancel and you're going to get 100 times 1.8 plus 0.7x. And now we just need to solve this equation. So 60 times 12 is going to be 720 plus 60x equals 100 times 1.8 is going to be 180 plus 70x. 100 times 0.7 is going to give you 70. All right, so now we want to combine our like terms. So we're going to move the 70x to this side. And we're going to move the 720 to the left side. Sorry, to the right side. And then 60 minus 70 is going to give us negative 10x. And then 180 minus 720 is going to give us negative 540. And then lastly, we're going to divide by negative 10. And we're going to get 54. And since 54 is not going to create an issue with domain here, now we know that what we have to do is add 54 milliliters of the 70% solution to the 15% solution, and then we'll end up with a 60% solution. And by the way, once you add 54 milliliters of the 70% solution, you'll end up with 12 plus 54 liters total solution. All right, so the answer here is 54 milliliters of 70% solution to your existing 12, and then you will have your 60% solution. So now you can try this little guy in much the same way, and then we're going to go to a distance problem. It says here that Sandra is rowing a canoe on Stanhope Lake. Her rate in still water is 6 miles per hour, so that's without any current. It takes Sandra 3 hours to travel 10 miles round trip. Assuming that Sandra rowed at a constant rate of speed, determine the rate of the current. So basically we are given her speed in still water and the time it takes her to travel with the current and against the current. So when you have the current with you, it means that it's going to help your rate of speed get faster. And when you're traveling against the current, it means that it's going to slow you down. So all we're going to take here is to remember that we have a little formula back in the day that I used to like to call dirt. And it's because it has D equals RT. So if you can imagine that the equal sign is an I, it spells dirt. And basically it means distance equals rate times time. But in this case, we want to determine the rate of the current. So we know what the time is. So if we solve this equation for time, we will have time is equal to distance over the rate. Now the distance we know is going to be 5 miles because it says that it takes Sandra 3 hours to travel 10 miles round trip. That means that it's 5 miles there and 5 miles back. All right, so the distance is going to be 5 miles. So when you have the current, so you want to make a little table here. You have with the current, and then you have against the current. All right, and then of course you're going to have the total time. Nice little story here. So when you have, when you know that the total time is going to be 3 hours, so we're going to add and equal 3. All right, we're going to end up with 3 eventually. All right, so what we're going to get for the first part with the current is if you use this formula here, time is equal to distance divided by the rate. And if we call the rate R, the rate in still water, if we call that R, then with the current, you're going to have 6 miles per hour plus the rate of the current, because it's helping you. And then over here, you're going to have 5 over 6. You're still going at 6 miles per hour, but now because the current is against you, you're going to subtract the rate of the current. So you get 5 over 6 plus r, and then 5 over 6 minus r, and total time is going to equal 3. So just to recap, we're using this formula, time equals distance over rate. So this is the time with the current, this is the time against the current, and this is the total time. So obviously these two should add together to get 3. So now we have our equation, and we want to multiply by the least common denominator, which in this case is going to be both 6 plus r and 6 minus r. 6 plus r and 6 minus r, and then of course 6 plus r, 6 minus r. So here the 6 minus r's will cancel, here the 6 plus r's will cancel, and you'll end up with 5 times 6 minus r here. Here you're going to have 5 times 6 plus r, and then over here you're going to have 3 times 6 squared minus r squared. And that's because here you have 6 plus r and 6 minus r. There's a difference of 2 squares. When you have a plus b, a minus b, so it's going to be a squared minus b squared, so it's 6 squared minus r squared. 6 squared is 36, and 36 times 3 is going to be 108 minus 3r squared there. On this side, you're going to get 5 times 6 is going to be 30. So 30 minus 5r plus 30 plus 5r, like that. So what's going to happen on the left is that your negative 5r and your positive 5r are going to cancel. Yay! So you have 30 plus 30, which is now 60, equals 108 minus 3r squared. So at this point, we want to subtract the 108 to the other side. I'm starting to write a little lopsided here. Let me see if I can squat down here a little bit. And 60 minus 108 is going to give us negative 48 on that side, equals negative 3r squared divided by negative 3 on both sides. So r squared should equal 16. Square root both sides, and so r will equal plus or minus 4. And so in this case, neither of those answers will cause an issue with the domain of the original equation. However, we don't usually use negatives when I'm talking about actual rate of speed because it doesn't make sense in this application. So we want to say that our final answer will be r equals 4. So the rate of the current is actually 4 miles per hour. All right, and that's how you do a distance problem. And so now we're going to let you try this distance problem. And then we're going to go to our last example, which is a work problem. And no, it's not the kind of work that you're thinking about in physics when you talk about force and that kind of stuff, but just work, like how long it takes for you to do something when you're working, okay? So it says here, every year the junior and senior classes at Hillcrest High School build a house for the community. If it takes the senior class 24 days to complete a house and 18 days if they work with the junior class, how long would it take the junior class to complete a house if they worked alone? All right, so we're given how long it takes the senior class working alone, and we also know how long it takes when they're working together. And what we need to find out is how long it would take the junior class to work by themselves. So if the senior class can complete one house in 24 days, their rate is basically 1/24. So 1 over 24 is the rate for the seniors. So we want to put that up here, big old fat S for seniors. Then we have juniors, and the juniors, we don't actually know how many days it will take the juniors to complete one house alone. That's what we're trying to find. So that's where we're going to use our variable. So we'll just, and that'll be 1 over x because we don't know how many days. So x is the number of days. And then we do know their combined rate. Their combined rate is 18 days. So it'll take them, in one day, they'll do 1/18 of the house in that day. I hope that makes sense. So you have the senior rate, the junior rate, which is what we don't know yet, and then we have the combined rate. All right, so all we have to do is add them up together, and they'll equal 1/18. That's all you have to do. So again, in this case, we want to multiply by the least common denominator, which is going to be, let's see here, we have to find the least common denominator. Obviously, we're going to have an x, but for 24, we know that 24 is 8 times 3, and 8 is 4 times 2. So 4 is 2 times 2, so I'm doing a little factor tree here. So 8 times 3, 4 times 2, so we're going to keep this 3. And then the 4 times 2, we're going to keep that 2, and then we're going to keep these guys. So this is how you do a prime factorization. So 24 is going to be 2 to the third power times 3. And then for the 18, we'll do the same thing. We have 9 times 2. 2 is prime, but 9 is not. So then we go 3 times 3, and then those are both prime. So we get 3 squared times 2. Now if you remember, when you find the least common denominator, it has to have each factor, and it also has to have the highest exponent of that factor. So for example, they both have 2 and 3 as their prime factorizations, but in the case of the 24, you get the highest exponent for the 2, which is 2 cubed. And in the case of the 18, you get the highest exponent for the 3, which is 3 squared. So this becomes your least common denominator, and 2 cubed is 8, and 3 squared is 9, and 8 times 9 is 72. So it turns out that our least common denominator is 72x. So we're going to multiply everything by 72x. 72x and 72x. Alright, at this point I'm going to erase my prime factorization or my factor trees here because we don't need them anymore. But I hope you understood where I got the 72 from. Alrighty, so now we're going to go ahead and say that 72 divided by 24 is 3. So this becomes a 3, so we're going to get 3x from here. Here the x's are going to cancel, and you're going to have 72 times 1. And then over here, 72 divided by 18 is going to be 4. So you're going to get 4x times 1, or just 4x. And that really simplified our problem here. So now we're just going to bring this 3x to the other side. And it says 72 equals 4 minus 3 is x. So basically, x equals 72. So 72 days for the juniors to complete a house by themselves. So clearly the seniors have a little bit more of a skill set or something when it comes to making houses, because it took the seniors only 24 days. Maybe their class is bigger, I don't know. But it's going to take the junior class alone 72 days to complete a house. So that is how you do a worked problem. And so now we will let you do this do-it-yourself question. This is part A, and then we will give you part B. And once you have completed this do-it-yourself question, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.